So today we start new topic. This is the unit 2 actually of your operation research, that is transportation model. Now what is mean by transportation model? This is a special kind of linear programming problem, you can say, where we want to supply from one supply location to the different destinations, you can say. Now, in case of transportation, we will have a different cost of transporting. Suppose in this slide, here the source is shown and the destination, these are the suppose three destinations are shown and the source is ABC. So if I want to supply something from source A to destination D, where the source supply available quantity is 50, whereas destination the requirement is 20. Okay, the cost of each transportation from supply location A to destination D is 5. In the same way, if the transportation cost from supply location A to destination E, where the requirement is 95, is the cost of transportation per atom will be 8. Okay, so in this way we will have a different cost of transportation and we need to transport different quantity. Now the main aim of transportation problem is to minimize this cost. Okay, minimize this cost. So how we can minimize the cost? Now as we can understand, suppose if you consider there are different supply point like A, B, A1, A2, A3 here, and there are different demand point like B1, B2, B3 and B4. Now here we assume that we can supply from any locations like from A1 to our destination point, that is demand point B1, B2, B3, B4. In the same way, we can supply from A2 to B1, B2, B3 and B4 likewise. So A1, A2, A3 like up to AI, okay, are the supply, whereas B1, B2, B3, B4, Bj is the demand points. Okay, now we assume Xij is the quantity of transportation and whereas the Cij is the cost of transportation. Now what we consider here, that Xij must be less than or equal to Aij. It indicates that we can supply maximum what is the supply available quantity, less than or max up to that. Whereas in case of demand, so Xij it should be less than or equal to Bij. Okay, like that. And how the equation will be considered here, that is summation of Cij Xij from I1 to m, where j1 to n, which is little bit not visible here. And we know the cost of transportation cannot be negative, so it will be always positive value, that is Cij must be greater than or equal to 0. When we can say balance problem, when supply summation of supply and summation of demand is same, that is called the balance problem. Okay, how we solve transportation problem? There are different methods available for optimization. Mainly two methods are available for optimization that we see in phase 2, that is modified distribution method. It's called the MODI, or it is also called the UV method, and stepping stone method. This is the phase 2, whereas we get the basic feasible solution by different method like northwest corner method, least cost method, and Vogel's approximation method. It is also called the penalty cost method. So first we'll learn how to get the basic feasible solution, and then we'll learn how we can optimize in the phase 2. So phase 1 is to find the basic feasible solution, and phase 2 is to find the optimum solution. Now the here we use different techniques to represent this problem. Like in this chart we are representing the supply and the demand. Okay, so that is you can say the locations where you want to send the material. Suppose you want to transport car from factory A, B, C, or you may say the warehouses A, B, C to the different distributor like D, E, F. And this is indicating the supply quantity, that is A location is having 50 quantity and B is having 40 quantity, C is having 60 quantity. So total available quantity is the summation of all this, that is 150 is coming. Whereas the different location demand is D, E, F, where the D requirement is 20, E requirement is 95 and F requirement is 35. If you add this is also coming 150. When supply is equal to demand, we say it is a you can say balance problem. If it is not, then what we do, I will explain that. So first we are going to solve this problem by northwest corner method, and we are going to find out the basic feasible solutions for this northwest corner method. Now I want to allocate the supply amount 50 to first northwest corner method. Now if you see this 3 by 3 matrix, you can say this is the northwest corner of this matrix. That is the first one, northwest. Now how much I can allocate at this condition? So how much is available? 50. How much is demand? That is 20. So maximum we can allocate the minimum of these two, you can say, that is 20 and 50. So though the supply quantity is 50 available, but the demand required is only 20, so I will allocate 20. Now once we allocate 20, it indicates that the demand is fulfilled for the destination D. So you can delete this miss, you can just mark one vertical line over here. It indicates that there is no requirement left for the destination D. Now next the remaining is, so I will show on slide. So the same problem is shown here. Okay, so 20 is allocated here. It indicates that now the demand is 0, and now how much is left over for the source A is 30. Okay, so destination D, E and F. Now once demand is over, you can draw one vertical line. It indicates that now you don't need to look for this column. Okay, now the next one, once you delete this, so how many which is the northwest corner for this matrix? Okay, so this is the northwest corner for this matrix. Okay, that is 1 2 location for this matrix, you can say. The 20 we have allocated, and the destinations is completed. The demand for destination is completed. Now how much we can allocate here? Okay, we can allocate the maximum 30. Okay, how much is our requirement? That is 95. So the current availability is 30 only, though the requirement is 95 for destination E. So we can allocate only 30. If you allocate 30, so this will become 0. So there is no supply quantity. So you can draw a horizontal line over this column row. Okay, so it indicates that there is no availability at the source A. Okay, so I will show that by doing this. So we have allocated 30 quantity for the 1 2 location, and because of this the supply quantity became 0. And how much is remaining here? The remaining is 65. So draw, just cut it and write down the new value required at the destination E. Now how many cells are remaining? These are the 4 cells are remaining. So how much is how we can which is the northwest corner? This is the northwest corner for this. How much we can allocate? Again, the requirement is 65 left over here, but the supply available for source B is 40. So we can allocate only 40. So allocate 40 here. Again, the source will finish because all the quantity which is available at B source will be vanished once you allocate 40 quantity here, and the remaining quantity just you can write down like this. So the remaining will be 20 here. So draw a horizontal line at this row, and this indicate that there is no quantity available for the source B. Now there are only 2 cells remaining, which is the northwest corner. This is the northwest corner. How much we can allocate? The source C, the quantity available is 60, whereas the requirement for this cell is max 25 left now. So allocate 25 over here. Okay, and once you allocate 25, so the remaining quantity will be 35. Okay, and the last which is remaining cell is this one, so allocate 35. In this way we have allocated at how many locations? See, 1 2 3 4 and 5. Okay, 5 locations are the where we are allocated. How we can find out the cost of transportation? Now this is the quantity, that is 20 are going to supply at the cost of 5 rupees per quantity. Okay, it indicates that 5 into 20, that is 100, will be the cost of transportation for this sale. Okay, in the same way you can add the cost of transportation of all sales, that is 8 into 30, 6 into 40, 9 into 25, 6 into 35, like that, and if you add all that, the total cost will be 1015 rupees. So in this way we can solve problem for by northwest corner method, and this is the total cost of transportation. Now one more thing you can understand for the feasible solution, that is the how many cells are available here, like sources 3 and destination 3, that is m, you can say 3, and n is equal to 3. So 3 plus 3 is 6. Okay, so allocation must be m plus n minus 1. Okay, and how many locations you are allocated, that is 5. The m plus n is 6, minus 1 means 5, so 5. So this is the basic feasible solution, and we will get the basic feasible solution by these methods. So this is called the northwest corner method.